Okay, we're recording. So today is our fourth class, and we are going to talk about the next two collections. We're going to talk about dictionaries and sets. Dictionaries are one of the most commonly used collections in Python, along with lists. And sets can be used on occasion, but they're less frequently used. So we're going to start out talking about dictionaries, and just like last class, we're going to kind of refresh on a lot of the concepts regarding dictionaries and kind of quiz you on them real quick, just for fun and to help you memorize it better. And then we'll move on to sets, and then we'll get into today's project. So can anybody remind me what the characteristics of dictionaries are? Just like, let's see.
They're unordered.
All right, we got one.
And any fails?
What? I'm sorry.
Fails.
Okay, hold on one second. We got some feedback. 1 second. Can you say that again? I don't know what you guys were talking. You say pairs? What? I don't know what happened.
Yes, fails. Fails. Key values. Key.
Hey Edgar, can you type it? Your microphone is kind of like it's got a lot of noise in the background, and I will read your chat message. I think you're on to whatever you're gonna say. I believe in you. Put out. There's actually 4 of these guys. All right, so while waiting for Edgar to type that, I'm going to just go on with elements are in pairs. Yep, perfect. So we have what's called key value pairs. And so rather than, if you imagine a list, got our list that's, A, B, and C perhaps. We call it a list. This is at the index 0, this is at the index 1, and this is at the index 2. Well, we can imagine those indexes as keys if you really want to think about it. At the key 0, we get the value A here. At the key 1, we get the value B. But we don't call them keys with lists, we call them indexes. All right? So we can take that knowledge that we're kind of accessing something, in this case with the list based on the position. Well, in the dictionary, we access it by a key. And that key can be a string to define, and can be kind of a human readable thing. It can also be an integer. It can be several things, actually. The most common of which are going to be strings for keys. So we'll generally have a key value pair, and we're going to dive into how that works. Anybody got any other ideas for some of the other things? There's 2 more that I want to focus on, I think.
It can have duplicate elements.
Yep. So I think what you're saying is there's no duplicate keys. So none of the keys can be the same. We can't, just like in a list, we can't have 2 things in index 1, right? There's only 1 value associated with that. And then finally, the last one's going to be mutable. So we can change our dictionary once it's created. Generally, the only immutable collection is going to be tuples, right? So if you ever don't want it to be messed with, you can do that. But dictionaries, again, are the most common, if not the second most common collection that you'll deal with in Python. So they're very important that you get nice and familiar with them. All right, so we're going to get rid of that list that's a decoy there. And we're going to dive into this. Does anyone remember how to create a new list or a new dictionary? Sorry.
Curly braces.
You got it. So if we want to create a dictionary, we would do just curly braces. And so this would create an empty dictionary. And so just like with lists, we can create them literally or programmatically. All right. So if I was to create it literally, that means I pass it all the key value pairs I wanted to start with and be creative with in the beginning, like right here in between these curly braces. Whereas if I do it programmatically, I add it one line at a time and add the key value pairs one at a time. So we can see that. You might think that you would just do like A is 1. So this is the syntax. On the left side we have the key, and on the right side of the colon we have the value. All right, and we would have them separated by commas. So we have B is 2 maybe in this case. All right, so we can see that, and this is kind of how it's structured. This is still this way works literally, and literally, generally speaking, if you have all the information at the beginning, I would create it literally. In this though, we generally like to make our dictionaries formatted in a slightly readable, more readable way. This might look readable to you, but when you start having like a lot of key value pairs, it gets pretty hard to read. And so what we can do is just press enter a couple times, and our dictionary ends up looking like this. So we have our starting point here. Our ending point is kind of at the same indentation level as where we store the variable. And then we would just have our key value pairs separated by commas, one indentation level in. This is really easy to read if you're in a hurry because everything is on its own line. And so that's pretty nice. And so again, we can access this. How would I access this? How would I access the element, the number 1 here? Or the number 2 actually. Let's do number 2. Anybody?
It's just the variable name, so D, square brackets, and the key name.
Which is going to be B in this case. And so if I do that, we're going to use the key to access this guy, and then we're going to get the value out of it, which is 2 in this case. You might notice that if we had a list, if we had this as A, and then B, and then I guess C or whatever, we would access it kind of the same way. L, square brackets, and then if we wanted the letter B, we'd say position 1. And we would print that out, and we'd get the letter B in that case. So the same concept, where with lists we use the index or the position to access our element or our data. And with dictionaries, we use keys to access that data. The advantage to keys is that we can start putting better informative ways of describing how we access the information. Generally with lists, when we're accessing an index, it's just a number. It's always just a number. But if we use a key, we can make it a human readable string, like my favorite number. And so when we access it, we immediately know the context of which the data is stored. And so we can pull it out. We don't ever really have to think about it. And we can say, well, my favorite number is going to be 1 in that case. And we immediately know what we're trying to access when we're using it. And that's really human readable, and that's really nice. And again, if you store each of these key value pairs on one line, you'll be able to immediately know, by reading this. It's really easy to read. Any questions about that stuff?
I have a silly question. Can you store instead of like one value, like a range of values?
A range of values?
Yeah, just
like a list?
like a list or.
Yeah. Perfect. Good question. All right. You can also.
Yeah, that was my question too. Like, if you have a key, can you have more than one value? Is it always just a pair?
Good question. So you can only have one value, but you can have a collection of values. So if we wanted to change this to a list of 1, 2, 3, we can print that out, and now your favorite number is apparently 3 numbers, which is weird, but It's still one thing, but if you wanted to combine multiple pieces of data, you can put a collection of data, for example. And when we get into object-oriented programming, you can actually store an object there, but that's 2 or 3 weeks out from today. All right? So you can still store multiple pieces of data. Now, one important thing is, like we said here in number 3, we can't have multiple keys here. So if we wanted to store multiple pieces of data, we do have to use a collection to store it, because we can't have 2 keys called my favorite number here. We can't do my favorite number again and be like the number 2. The reason that is because when we're trying to access our data, our value associated with that key, if we have 2 of them, it's not going to make sense. It's not going to know which one to go to. And so Python does not allow us to have multiple keys of the same name. It wants to have, for every question, it wants to have only one answer, if you want to think of it that way. So we can do that. All right. So moving on, if I wanted to add another letter like the letter C and the number 3, how would I create that key value pair?
Similarly to when you print, you would just put D, square bracket C, and then equals whatever your value was.
Yeah. All right. So we don't want to actually print it, but yeah, you're right. We can just say C equals 3. So the way this is doing it is we're kind of creating, so C is not currently a key here in our dictionary right now. And so we're creating a new key value pair on the fly. We didn't create it literally, and so this is kind of, if we wanted to do it programmatically, we could have started with an empty dictionary here, deleted all this stuff, and then added a bunch of them like this. We're going to just append, or not, append doesn't really work for a dictionary because they're unordered. Append implies that it goes at the end. Dictionaries are unordered. If we were to print this dictionary several times, it would come out, the key value pairs would print out in different orders every time. Now, with that being said, I believe just recently in Python 3.6, this particular version, they do kind of keep order now. So, however, generally we want you to learn how to write your code so it's backwards compatible and it will work with Python 2 and upwards. And so because of that, I would just say never rely on a dictionary to have order. If you write a project and someone else wants to install your project, I mean, you can tell them and specify in the installation instructions to use Python 3.6 and above, so or my dictionary has order, but you're not always going to need to do that. All right, so we can create a key value pair with this format. We just put D at the key we want to store it in and then store it in a value. So if you want to think about it, we could have just said my variable here equals 3. In this, if you want to think about it, a dictionary is a group of variables that are being stored together that all have the same context, or maybe they're related to each other. So in this case, we could store a variable like we've done in the past, just create a name and store it equal to 3, or we can use a dictionary in this case and give it a key, which is going to be like the my variable here associated with this dictionary, and we can store that value in there. All right, and then we can go ahead and print our dictionary at that key, and we'll see we get that value right back out of it. So dictionaries are nice because they're a collection that holds data in a human readable way, because your keys, you can obviously, you're probably not going to call them B or C or whatever. You're going to give them a nice name like first name or something if we're going to have a user. You can sometimes represent or model your dictionary after an object or a person or something you might want to store the data in. And so we can do, well, we'll see that later today. Any questions so far?
Yeah, what about the update function?
Good question. We will get to that in just a second.
Okay.
I'm going to demo all the necessary or common methods for dictionaries, so fear not. Good question, though. All right. So if you guys remember, I'm going to change this so this doesn't break later if somebody uses this. We can, actually I'm going to call this A again. And so what we can do here is if we ever wanted to access information, we can do just what we did here. So accessing values. So in this case, we can print out D at key A, and it's going to look up key A, and we're going to get this value, and we're going to print that out. We can do that, but there's a little bit of danger again here. If we print out D at the key X, and we have not defined X yet, Python's going to get angry at us. And just like with lists, when we had that index error or value error when we're trying to access something, in this case, if we're trying to find a key and it doesn't exist, we're going to get a key error. All right. And so ideally, it depends on when you're designing your code. Do you want your code to give you an error if something goes horribly wrong like this? Or maybe you're looping over something and maybe you're not concerned if the key isn't found. Maybe it's okay if we're trying X out and it doesn't work out. Maybe that's fine. So in that situation, there is another method we can use. Anybody know that one that doesn't really give a Python error if we're searching for something or accessing a value? This one's a little less common. All right, spoilers then. It's called .get. We can use .get and it works the same way. We can, let's say we do the key A, and let me just comment this out for a second. If we get A, we'll get the value, all right? However, if we then try and get the key X that doesn't exist, we don't get it doesn't blow up anymore. It says none here. And so the way .get works is we can specify what happens if it doesn't find that key. So I can say, I can give a message here. I just put a comment here and say key not found. And if I print that out, we will quickly see that the result of this is it's not being found. Make sense? So this is a little bit safer. Maybe you can give a message that describes what's going on, and it's not going to give you that key error that if you just trying to access it before. The way we handled that before with lists when we were using index to see if something was a part of it was we quickly checked using the in keyword. And we can use the in keyword here with dictionaries as well. So we can do that. All we got to do is print, let's say, the keyword A in our dictionary that is named D. And if we do that and we run this, let me comment this out for a second. We can see that the key A is in D. Now, if we try and see if the number 2 is in D, that's going to be false. Now 2 is in here. Why do you think that's happening? Anybody? Bueller?
Is it because you're not accessing the key? You got to do everything through the keys?
Yep. So by default, when we're using the in keyword and some other things that we'll see, it only looks at the keys. We're not actually checking the values. If we wanted to check membership for the values, we would have to do an explicit command, which I'm going to show you here in a little while. All right. So by default, it only checks the keys. A is a part of the keys. 2 is not. And so again, we can check some, the letter X. Is it in the keys? It's not. And so we can check that really quick. That's useful sometimes. Again, if you don't want to use the .get method and you want to access a key and you want to be sure it's there, you can check if it's in the dictionary keys first before you try and access it. And then you won't cause any trouble. So regarding to the question we had earlier, update. So there's another method called update. And this one's pretty interesting. So we can create a second dictionary real quick. We'll say D2, and then we'll say the letter C is 3. I'm not very creative right now. I'm sorry, guys. And D is 4. And so if we wanted to update our original dictionary with our second dictionary, what do you think updating would mean regarding a dictionary, like just within like a normal vocabulary, normal like word dictionary that we see?
Adding D2 into D1.
Yep. So basically, what
Does
update?
that have to do with the mutability?
It does. We're mutating the first dictionary here, D. All right. And so what it does is update. It will add new key value pairs and will overwrite key value pairs that D2 has that are similar or the same, not similar. So in this case, I'm going to show you this. I would just do D1.update with D2. So this is the dictionary we want to mutate. We are updating D1 with the contents of D2. And so if I run this, I can print out D1 afterwards. And I meant D. That's why it's angry. And if I run this now, that I've done it, we can see that A is still 1, 2, 3, and B is still 2, but now we also have C and D, the key value pairs from D2. And so that's nice. It kind of combines the dictionary. If there's a key value pair that's not there, it's just going to add it to the first one or mutate it. Now, if we have an overwrite and we have a duplicate, remember that, I don't know, I'm going to put the word no. Remember that keys are unique, and so you're never going to have two keys called A. And so if we're updating and we have a second key in this new dictionary that we're adding to the original, instead of adding a second key value pair called A and having a duplicate, it's just going to overwrite the value here in A with the value in the new dictionary we're adding to it. And so if we can see here, A is now overwritten with the word no, and all the other ones are added just like you think. Make sense? The nice thing about .update is that this way, when we're just kind of creating key value pairs like this, where we just do it one at a time here, .update, you pass it an entire dictionary, and so you can actually add several key value pairs at one time, and that's pretty handy. So that's pretty much how .update works. Make sense? Any questions with that? All right. You guys are quiet again today. So next part, we're going to do...
Can you please explain the override part again?
Can you say it again?
Can you please explain the override part again?
The override? Yeah. Gotcha. So in this case, remember, one of the characteristics of dictionaries is there are no duplicate keys. All right, so if the key is A, and we're trying to combine two dictionaries, and both of those two dictionaries we're combining have a key called A, that's not going to work. We can't just put them together. We have to kind of figure out that conflict ourselves. And so the way Python has it is the dictionary we're updating, we're taking an original dictionary, we're updating it with another dictionary, a second newer dictionary, if you will. And so what it does is it takes the value from the newer dictionary that we're updating the older dictionary with, and it overwrites that value here. Because there can only be one key called A, and so it's going to pick the one from the one that we're updating with. Does that make sense?
I get it.
couldn't hear you. Was that good? I don't know.
Yep, I got it.
Okay, cool. Great. All right, so the next part really quick is we're going to talk about removing elements, and I'm going to go kind of fast. This is going to be just like lists. We didn't really cover del. Del also works with lists, and we can just see if we delete a key value pair, if we say D at the letter C, and then we print out D here. We don't need D2 anymore either. We'll see, let's do B. It removes the key B. So in that case, we're just removing an element at that key, and we get rid of the key value pair. Another way we can do this is we can say, D dot pop. So pop works with both dictionaries and with our lists, and so we can say pop the key value pair B out, and we can then print the element, and we can print our dictionary afterwards. And we'll see that we get the value popped out of it. Just like when we pop something out of our list, it takes the element out, it returns that, we can store it there if for whatever reason we want it. Sometimes you would want it to print it out saying we removed this thing, provide a human readable message, and then afterwards we can see that our dictionary has that key value pair removed. Removing elements from a dictionary is pretty straightforward, so I'm not really going to dive too deep into it. Again, with any of what's up?
What about dot remove method? Does it work?
It don't. Hold on, let's see here. I don't think dictionaries have a dot remove. I don't remember. Maybe it is. It does look like it exists. I usually use del or key. Where's Python? One of these has to work. No, that's the thing. No, I think generally we just use del and pop. I'm pretty sure remove only exists for lists. All right. And the reason actually that would be, that makes sense now, because your values can be the same if you want to think about it. We could have multiple values that are called 3, for example, and if we do dot remove, it's not going to know which of those values to remove, which of those key value pairs to remove. Remember, it can't just remove a value. It has to remove the entire key value pair. And because dictionaries are unordered, it's not going to know which, remember list, if you use dot remove, it'll take the first one. There is no first one if it's unordered. And so you can't reliably expect a key value pair to be removed, especially if the values can be the same between different key value pairs. Does that make sense?
So in list, the dot remove method takes the element, right, which you want to remove, and it removes the first element.
That's correct.
But even in dictionary, we can, like in pop and del method, we are putting the key, right, because keys are unique.
Yes, keys are unique, but remember, remove was, I believe, removing based on the value. Delete will do the same thing here, and print. We don't need a third way of doing the same thing.
But list has 3 methods to remove: pop, remove, and del, right?
I didn't write Python, man. So
that is what I was, confused about. Like list has 3 methods.
It's a good question. I'm not exactly sure why it's not there. I'm pretty sure it's not there. I've always used, So if we look at how to remove a key, this will probably be pretty good. They always use pop or del. It's just I can't tell you a good reason why it's that way and why there's 3 ways to do it in lists and there's only 2 in dictionaries, but I would say it probably is related to order. All right. So
there's a question in the chat.
Oh yeah, thank you. How do you update a dictionary where the values are in a list within the dictionary? So are you talking about if the values are like this, Edgar? Because if they're like this, it'll copy over just fine. The value can be. Edgar, you're gonna need to type it out. Your microphone's a little bit funky, but I'll read the chat. But yeah, anyways, it does not matter. The values of a dictionary can be any data type. And this is how we end up with nested structures. You can have a list inside your dictionary. You can have a tuple. You can have another dictionary as a value inside your dictionary. And so we'll learn how to handle those in the next week as we keep going. But generally, when you're using update, or every time when you're using update, Edgar, I'm trying to predict your question, you always send it a dictionary here. So you wouldn't necessarily send it like a list or anything. You'd always send it a dictionary. So it knows which key value pairs to update and change or add or overwrite. Make sense? I'll check your question when you type it out. All right, so moving on. I'm going to show you. Okay, cool. I guess I got your question. All right. So if you want to use your imagination real quick, we could do, we'll do user 1, and we can maybe store emails. Maybe I should do. And then I'll do one more just for fun. We could do George. Not spelled correctly. So in this case, you can quickly see that we can also do things like user equals. And this would have been helpful for the Game of Thrones project we just had. We could do something like a little bit more usable is like first name, Bob, and then last name is I can't think of a good last name. I'm gonna just last name. I'm not original right now. And then you could say like email is something. And so you can quickly see how I know I was not consistent with my quotation marks. So you can quickly see how this can be really useful using a dictionary, because now I can immediately see if I'm trying to access Bob, I would just say user at first name. And I'll know whatever value I get is that guy's first name. I don't have some arbitrary number like for an index like we do in lists, since that's a lot more human readable and it's quick to understand. All right, so I'm going to comment that out and we'll dive into this part. All right, so when we're dealing with this stuff, I'm going to move this up here actually. So when we're dealing with this stuff, we can have a bunch of key value pairs like this. And again, I want you guys to get in the habit of creating your dictionaries like this if you do it literally. Where you start it here, you press enter, and you have all these guys tabbed, and you close it out with this one that's unindented. It's very readable. So there's a couple other methods we can have with dictionaries. And the first one is going to be the keys. So we can do d.keys, not leaves, not lays, please. All right, cool. And so if we print this out, if I put an equal sign here, we can see that if we print that out and we run it, we'll see this thing. This looks pretty weird. I want you to pay attention to this part. What it does is it turns all those keys, only the keys, into a list. And so we see that list right here of each of those 3 keys. Now you might be thrown off here by the word dict keys that's kind of in parentheses around that. That only happens in Python 3. It's a newer feature. And what it does is it kind of provides a wrapper that's kind of a little bit more context. If you just saw this, you think it's a list. And you might not remember that it's the list of keys, for example. So Python 3 decides to go and kind of put kind of a label on that. Now, in terms of functionality, this is going to operate just like a regular old-fashioned list. You can loop over it and all those fancy things. So don't be thrown off by the fact that it says dict keys there. All right. If I print it, if I loop over it, if I do for key in keys, print key, we're going to be able to get each of those 3 users just like you might expect. So nothing too wild there. Note with for loops, remember we're looping over. This forms a list, and we're just saying for singular of that thing and plural of that thing, and we'll just print out each one. Any questions so far? All right, fine. We can also do values. And the way that's going to work is it's going to get all of the values, all of the data that are stored in the keys. Sometimes you might want to only look at the data that's in there to see if, you know, some piece of data is present. Sometimes you want to check if a key is present. You don't always know. Okay, whoops, I need to make that value. And now we can see that we have the same kind of thing. We've got dict values here, which is the label basically, and it still operates like a list. And we can see that here we get each of our email addresses. These are pretty useful methods here, dot keys and dot values. And before I move on, I'm going to put in a note here, dictionaries when using in keyword or for loop go over dot keys by default. So what I mean when I say that is, let me move that down here actually. We can actually do for key in D, print key. I'm not saying D.keys here like I did before. I'm just saying in D. And if I do that, we're going to be able to loop over that because by default Python does D.keys if we don't specify. So generally if you ever see in D or you're looping over D like that, it's just going to be the keys, and it's important to know that so you know how it's going to behave. Alright? If you want the values, we would just specify dot values and we would use that. Any questions? All right, cool. So just to elaborate, there's one more thing we can do, and this is the most common one, and that's going to be for key and d.items. And what that's going to do, I need to actually put key comma value. And what that's going to do is it's going to get these two things, the key and the value, as pairs. Normally, if you had a for loop over a list, for example, it's always going to get just the element or the data. But if you guys can remember the last, I think we did it in the last projects for the Roman numerals, we used something called enumerate, and we got the index of the list at the same time as the data at that index. So dictionaries have the same kind of thing going on if we use dot items. So now what we can do is print key comma value, and we'll quickly see that we get both at the same time. That is really useful. This is a very commonly used method because generally if we didn't do that, if we were just doing for key and D, print key, just like we saw before. If we wanted to get the value, you might think you'd have to do print D at key. What did I do? Then you put parentheses. One thing between Python 3 and Python 2 is Python 3 always wants your print statements in parentheses. So as you can see here, we can access the value, but in this case, we got to do our dictionary name, square brackets, and then the key. And we can do that, and in this case, it's fine, but sometimes your key name or your dictionary name is going to be really verbose. Like, it's not going to be D, it's going to be my dictionary. And this is going to be like user something, you know, and this gets really long. And when you start putting nested structures, remember how we had a list in here inside of our dictionary? When you start having nested data and nested collections, your text can be really long if you have long names for your dictionary or your keys names. And so it's nice to have a good name for these guys. And so what you can do is if you just use key value in a with dot items, you don't have to reference your dictionary name or anything. You can just say value or whatever you call it. Sometimes people say K and V. When you start dealing with nested collections and you start having ones inside there, I recommend you give them better names than key and value, because if you have another dictionary here that's your value, you can't really keep repeating the same variable names, key and value. Otherwise, it's going to be conflict variable names. Make sense? Any questions? All right. Really quick, I'm going to go into sets. Characteristics. Anybody?
Can't have duplicate values.
That's the main one. If I could type it. There we go. What else?
Unordered.
You got it. What's the other one? I think it's, yeah.
Mutable.
Yep, you guys are getting good at this. I know this is a little bit monotonous to think about these guys, kind of the characteristics. Let me actually find a slide really quick. But the advantage to knowing these different characteristics for each of these is that when you are ultimately, you know, designing a project or figuring out how you're going to do things, you'll be in charge of what this looks like. And so here's a quick table really quick to show off here. I'm going to link this really quick. But you can quickly see that here's the characteristics of all of these guys. And it's really nice to know these, because sometimes when you're deciding, well, does order matter? That'll help you pick which collection. Does it need to be mutable or not? And you can quickly reference this table, which you'll hopefully memorize. And then you'll be able to decide which collection makes sense. As we start moving forward from this, now that we've introduced these 4 main collections, I will be asking you which collection makes the most sense. I'll actually be doing it today when we get to the project. And I want you guys to think about these characteristics to decide, because ultimately when you are set free in the wild, we're not going to be there to hold your hand to say you should use a list for this or a dictionary for that. We need you to think about these characteristics, and that's going to help you make an educated decision. All right, so really quickly, now that we've done these, I'm going to kind of fly through this. Sets, basically they have 2 main uses. They're less commonly used, just like tuples are less commonly used, sets are also less commonly used. A quick thing to use them for, if we have a list and we have a bunch of repeated data, we can change our list into a set, and we can just do set and put our in parentheses and throw our list in there, and we can print out our set afterwards. And we can see that it removes all the duplicates and only has unique values. This can be really helpful if you guys remember the email thing that we just did for the Game of Thrones project on Monday. We could have let that list populate and just appended everything, turned it into a set, and then turn it back into a list. So one thing we can do is dupes, and we can just say, we can turn our set back into a list here, and we can print out no dupes, and then we can see that it's a list again. And that's pretty handy. If you want to remove duplicates, change it to a set, change it back to a list, and you're good to go. Be careful with this because sets are unordered. I know we're in Python 3.6, that might be fixed there too. But in general, that is one way to solve a problem. Now, notice when we created a set, it's in curly braces, much like a dictionary is. Well, the difference is that a dictionary is going to have the colons in between it. So if we just had, if we did this, and we print out a set, we're going to be able to see that it looks like this. No colons it's a set. If it's got colons, it's a dictionary. Any questions with that part?
What about white space, or if you were just put an empty string in a set?
Like this?
Yeah.
So white space still counts as like data, if you imagine. Now, because it's empty and it doesn't have anything in there, that would be a falsy value if you put that in an if statement, which we're going to cover falsy and truthy values a lot in the future. But it still treats this as data. Like if it was truly white space, we wouldn't have put anything there. But because we decided to put an element there or some data in there, it knows that it probably is somewhat meaningful to us because it ended up there. And so it's still going to say this. Now, again, if we put a lot of these, it's still only going to find one of them. Then if you imagine if we put one with an actual space, then it'll find both of those different cases because this is a different string than this is. All right.
Is there a reason why it's the white space came first after the numbers?
No, they're unordered.
Does it distinguish between single quotes and double quotes?
No.
Like if I put a double quotes one,
So if
will
I
it
put
take
double
the
quotes here, it's going to be the same. Just like the way Python interprets single quotes and double quotes, it does not distinguish those as long as you're consistent. Good questions. All right, so one last feature about sets. I'm going to Google this again. There is actually a video on this in our course, and I recommend you watch this. One thing is, if you have, if we have this giant email list, and we have it like, a@b.com, c@d.com, whatever, and let's just assume 1,000 emails long, more than 1,000, whatever. Now, if you were just trying to check membership and see if something was present in there, if I was trying to say if a@b.com in giant email list, that command would take pretty long depending on the length of our list, because it's going to have to go through and check each of them. All right. However, sets are pretty cool. I'm going to just say this would take a while. I'm going to write pass. However, if we change that set giant email, I guess I'll just say giant email set equals set on that guy, and then we try to do if a@b.com in giant email set, this would happen in one operation because it's a hash. All right. So the different, basically, this is kind of detailed, and you might ever have, like, if you have a giant, if you got a database and you're storing everybody's email address, or maybe like user logins or something. Say somebody's trying to create a new username, and you wanted to make sure that that name is available. Something that commonly happens when you find out you're not original or creative. If you're doing that and it was stored as a list, you would have to exhaust the entire list. Kind of like, imagine there's a for loop and you're checking, comparing in each one. However, if you stored all of those emails as a set, it would be able to do that one operation, one line of code, and it would be done, and it would know whether that is present there. And so why, you might ask? Because sets are hash tables. And you can see that the complexity of time for a search is 0 to the first power, which is just going to be 1. And so it happens a lot faster. And there's this wonderful, really hard to read Wikipedia article about this. And so if you're really curious about it, you can read about it. But I believe Santiago has it covered in this hash table. thing right here. So I'd encourage you to check that out, but basically that's the only other time you use set. The first reason is to remove duplicates, and the second one is if you're going to take advantage of its properties as a hash table. Unfortunately, I don't have time in this class to dive into details about a hash table, but hopefully that video and maybe your own self-learning should be able to do that if you're interested. It's a little bit complicated. Any questions about sets?
Okay, if we put empty curly braces, it will create an empty dictionary, right? So like if we put a comma or something like in list, we have to put a comma, right? Or tuple. Right?
Put a comma where in our dictionary?
Yeah, if we put only empty curly braces, it
Your
will create
microphone.
an empty dictionary, right? It won't create an empty set.
Oh, if you do like this with a comma?
Will it create an empty set? Because without comma, it will create an empty dictionary, right?
Oh, yeah. Oh, that's a really good question. Well, I don't think this is going to work because you'd have to put some data on the other side, right? You'd have to say like A. Otherwise, if we just did this, new set, I think this is going to blow up. Yeah. Python's unhappy with this because you'd have to have some piece of data before the comma. How are set and dictionary used with functions? We will see how sets and dictionaries used in functions, but they would be used just like lists or anything else. You just pass it to the thing, and they're mutable. We're going to see that in today's project, though. All right, so I'm going to dive into it. I'm going to link this guy right here, and let's get into today's project. Hopefully, I've allowed enough time for it. All right, so today's project is that what we're going to do is we're going to, again, because dictionaries are the most common, if not second most common between lists, they're both, maybe they're tied for the most common collections. We're going to focus on dictionaries today a lot. And so what we're going to do is we're going to rebuild something we all really take for granted. What we're going to do is we're going to, oh, hold on one second. I meant to paste that. One second. There we go. What we're going to do is we're going to rebuild something we all take for granted. And the reason we're going to do this is because, first of all, it makes us appreciate things that we have in our lives. And second of all, it's really good practice. Breaking something down that we don't even think about and turning it into a Python program. So today we're going to build a calendar. And we're going to figure out how we're going to do that. And we're going to make it so ultimately when we're done with it, we can store activities and stuff in it. And we're going to build this from scratch in Python. And we're not going to use any like other applications or anything. We're going to build our own calendar that would actually work. Now, I still wouldn't use this over like Google's calendar, but it's pretty cool to be able to build like a rudimentary one. All right. So I'm going to describe what we're going to be building. We're going to be building, this is not like a year-long calendar. We want to build a month, just 1 month, and probably like a current month or whatever. We'll be able to pass what month we want, and then we should be able to get a calendar out. And so the things we need to keep in mind are what will we need to build a calendar? What pieces of information will we need? Anybody?
The date, of course.
Mm-hmm.
Date, days.
So yep. So the number of days, and then more specifically the date, the first day of the month, because we want to know, does that month begin on a Thursday or a Monday or whatever? If we have the number of days and the first day, we can build the rest of the calendar. Does that make sense? So that's what we're going to do. So the first thing we want to do is teach Python that stuff. If you guys remember the Roman numerals project, we started out by teaching it what each Roman numeral character represented as a number. All right, and we built some function to do that. Well, now we have better tools to deal with that, and so we're going to use those. So how would I start with that? How would I tell Python and store a number of days associated with each month? Each month. Wow, I can't talk.
Create a dictionary?
You got it. So the reason we chose a dictionary here is because we're thinking about key value pairs. We'd want a month name and then the number of days associated with that month. And we don't necessarily care about order. If I plug in the key January, I'm going to get the number of days in January. I don't care whether January happens first or the last thing in this dictionary. All right, so I'm going to create days per month. And I'm going to create a dictionary. Just like I said, I'm going to create this. I'm going to press enter. And that's going to move this one here. And then I'll have white space here. And then I can just do January, 31 days. This is going to take a second, so I am going to copy and paste it because I have the answer. So that's what it's going to look like ultimately. We're going to see a dictionary. And the advantage of this, again, we don't need order, and we just want the key value pairs in this case. And also, a lot of us think we have these memorized, but we don't. And I don't want to get the wrong number of days in front of you guys. All right. So that makes sense. We now have the number of days in each month, and so we're getting there. We can almost, so we're going to write this. We're going to say build empty calendar, and I want to be able to ultimately pass it the month name and the first day, right? So the other half of this is Python does not our program does not currently know the order of the weekdays, right? It does not know Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. What type of collection do you think I should use for that?
Probably a list if you want your order.
Got it. Perfect. And so exactly. This is where I was saying it's important to know those characteristics of your collections because our list in this case is going to retain the order. If we were trying to store the weekdays in a dictionary, first of all, the order is not going to retain, and suddenly Saturday is going to come after Tuesday and all that stuff, and it's going to ruin everything. But also, some people, once they learn about dictionaries, are like, well, make everything a dictionary. No, not necessarily. Because, remember, dictionaries have key value pairs. And so for every value, which would be our weekday in this case, we need to come up with some kind of key to associate it with. And we'd have to make something up for that. This doesn't make sense in this case. We don't have Monday. We can say first day is Monday, and the second day is Tuesday is the key. But that doesn't make sense because the first day is not always going to be Monday. So if you're ever in a question where if you should use a list or a dictionary, and you're just trying to throw out the word dictionary, think about, well, am I going to have to make up keys, or are keys going to come naturally? In the case of our months, we already have our key as our month name, and our value is the number of days. It's very intuitive, and we don't have to think of anything. But if you're in a situation where you have to think of a key name to access that value, maybe you should use a list. Does that make sense? So we're going to store it in a list, and I'm just going to do Monday, Tuesday, put some quotes there. Wednesday. This is really painful to type. All right, beautiful. And so note that what I did here was, and you could even go so far as to like indent this one again if you want to. But all the things here are indented after here, kind of like you would use if there was like a control flow block, like an if statement. So we know that all these are a part of this. And the reason that Python isn't angry is because we started an open square bracket and we didn't close it yet. And so it knows it's waiting for that closer before this thing is done. So any questions so far? Nothing? All right. This part gets tricky. And so before I even write anything, what should I do before I write the code in my function?
Test cases.
Yep, you got it. So I'm not going to type these out. There's a lot of them. So let's look at what I've done here. We've got this test case written for February, so I know it's not February, but this is, I don't want to rewrite this. And so in this case, we're going to call our function. Hedger, that is an excellent question. We will tackle that at the end of class. He asked about leap year, and we will handle that at the end of the class. Awesome question. So we're writing our test cases. So this is actually how we want this thing to work. I knew, but now you guys can see. We kind of want to write it so we have the weekday, a comma, a 3-letter abbreviation of the month, and then the day of the month. And that month number will go all the way up until we reach however many days are in our month there. And we can also see that we're kind of rotating through our list here. You know, it doesn't matter if we start on Thursday. We know that the next day will be Friday, Saturday, Sunday. And we can also see that in that list, it's doing something really cool. It's starting over after Sunday. Rather than, if you guys remember with the Roman numeral project, it's when we went over out of index in the list, it gave a Python error. But instead of doing that here, we've trained our Python code to restart at the beginning of the list after it reaches the end. And so we'll have to find a clever way to do that here today. And so ultimately, we want to make a dictionary for our calendar. And on the left side, it's going to be this date in this format, and we're going to kind of have it increment. And then the value is just going to be none at first for all of them. We're doing it that way so that we're kind of starting out with an empty calendar, and the value is ultimately going to be where we store the task or activity for that day. And so this is the expected after we build our calendar. It should look like this, and then our search statement just says the calendar we built should match this thing. And then if it works, we say all good. And so again, this is test-driven development, which is the acronym is TDD, and we know how this thing is supposed to work and look before we write any code. All right, that's very important. It's good to have a good vision of the direction you're going. Some people who are new to programming just like have diarrhea of the fingers and just try things out and hope it works. I want you guys, I mean, maybe that's how you start, but I want you to just build into having a direction with your code instead of just trying everything out. Plan it out, maybe write a draft or some pseudocodes, as it's called, when you kind of know where you're going to go and you translate that English or Spanish into code. All right, so now we're going to start building the function. Any idea on where I should start? Essentially, we're going to pass it like a month name and the first day of that month, and we expect this function to build this thing. And so rather than be intimidated by, yeah, this is a finished product, of course, but think of some really basic starting points from this. How are we going to get this data? So we can look at each of these three things. We can say, well, we have to have the weekday, kind of keep looping around and going from, you know, Monday to Sunday and then starting over, depending on what day it starts. We have to have a 3-letter abbreviation of the month, and then we have to have the day of the month. And we know that the day of the month goes all the way up until the end of that month, according to this number. So any ideas? We can tackle one of any of those 3 properties there that we need, and we can try and solve that.
Well, I think you're definitely going to have to do some looping, some iterating to get some information, even if it's,
Yep.
I mean, once you have your month.
Oh wait, I shouldn't. So what kind of loop should we use? I just spoiled it, but
Yeah.
why should we use a for loop over a while loop?
Well, aside from the possibility of an infinite loop.
That's pretty much it. Yeah. We know it's going to end when it's supposed to end. It's not. It's going to exhaust itself. And so we can take the for loop problem first. We know it's going to start at 1, and we know we can use a loop to change these numbers all the way up to the number 28 in this case, right? How do I loop through that like that if we know the exact numbers we want to loop through?
Range.
Perfect. So I'm going to just say I. I'm not going to give it a cool variable name here. And range. And what should our range be from?
It's like 1 to 29.
Okay, perfect. Now, that is correct for February. What about whatever month we're in? We want this to be dynamic, right?
Mhm.
So how would I get a dynamic number?
You could just get the key from the days per month
Right.
dictionary.
What's the code for that?
It would be the dictionary square bracket name of your key.
All right. So we'll just say month. We're actually getting past the month name here. And then you said 29, cleverly, because you know that range is not inclusive of that last number. So we need to add 1 to it, just like that. One thing we could do, we could say, if we want to, days and month, we can separate this in a variable so it's a little bit more human readable. And we can just do this, plug this guy in over here, and then paste this guy in right here. Just so we have another variable, so it's like if someone else was reading through this code, we would kind of walk them through it. Because you want to be pretty friendly to your fellow coders. All right, so we've got the range. If I were to print out I in this case, we can see that if I run this, we're getting 1 to 28. So, all right, we've done step 1 of 3. How do I get the first 3 characters of the month name?
By slicing the key.
Say it again.
By slicing the key.
Yep. And what would the slice be?
It'll be :4.
All right. So we'll say month at 0:4. And so I will also print out the abbreviation. That's what that. So we got 1 more. We actually want 0 to 3 in this case. Remember, 0, 1, 2 will be the first 3 characters. So if I do this again, we get Feb. All right. So again, rather than panicking and seeing this finished product and just thinking, how do I get from 0 to that? You can see that we've broken this down into one little part at a time, and we're going to try and solve each of those individually rather than just hyperventilate at seeing this. All right. And so we're doing that. Now we've got the month abbreviation, and we've got the number going up to there. Now, the weekday is the hardest part. So before we get to the weekday, let's do a freebie. We know the result is a dictionary. So I'm just going to create another dictionary. Calendar is an empty dictionary. We're going to start it as that. And we know somewhere in this for loop we'll populate it. All right. So at the end, though, we're going to return calendar. I'm really a fan of taking some freebies, getting some freebies. Like, I know this is obvious, but if you're like facing a problem like this that you might not know how to solve, sometimes it builds confidence, and it's just nice to get something on paper or code or on your screen so you feel like you're moving along with it. So we've done that. We've got I is going to be our number of our day number. Feb is that. So now we need to we have the first day, all right? And so this is tricky. Some of you guys might think, how would I deal with the weekday? You might think, print out days at I. So as soon as that stops yelling at me, That's not an invalid syntax. Whatever. We can see that this thing works kind of up until it runs out of the index range. But another problem with it is that we're starting with Tuesday. It said start with Thursday. And so by default, remember that the first day of the month, this one does not actually correlate with this list of weekdays. Our weekday here in this case is at index 1 is Tuesday. We need our weekday to start at Thursday. So can anyone think of a clever way to find out how to start at Thursday, how I would reference this? This is kind of tricky. How would I find Thursday? Let me rephrase that question in this list.
I mean, would you just do the dot index?
You would. All right, so we're going to do that. We're going to find our starting day. We'll say index equals days dot index at first day. And so now what we can do is we can print out, oops, apparently that parenthesis really wanted to go with me. We can print out our index, and we'll see that we get the index 3. And so now what we can do, if we do that, we can say, well, in this case, we can print out index for a second, and every day is suddenly Thursday. Well, we can print out days at index, and now every day is Thursday. But we're at our starting point now. And so all we have to do, if you want to use your imagination, is increment by 1 for the index every time that for loop happens. And so our index plus 1 will get us to Friday. And then we have some problem that's we're going to have to figure out when we get to Sunday. Does that make sense, everybody? Any questions with that? So any idea on how I'm going to increment my index? Knowing that the index is actually separate from this for loop I. We can't just use I because, again, I is representing the date, and this 1 here from our I does not necessarily represent the index of our days, our weekdays. Now you could make them match and you could do some complicated code, but we're going to do it a cool way. There's a lot of different ways to solve this problem. All right.
Like we can do index plus equal to 1, and if and if index is less than 7, we can use that thing. But if the index is more than 7, we can just reset it to 0.
Perfect. Amazing. So all we can do. So this is kind of weird, but I always feel weird like keeping track of a variable like index here. We can do index plus equals 1 here every time this while loop happens, right? Or the for loop. I always feel weird keeping track of a variable inside of a for loop when the for loop is supposed to increment something. But there are cases where you have to kind of increment 2 different separate things at the same time. And so we're going to do that. Right now it's still going to break. We're going to get to Sunday, but we can see that now that we started our index out, we created it, we found the first day, and now every time the for loop changes the day number, we're also going to manually change our index number and increment it by 1 so that our weekday number or index associated with the weekday also changes along with the actual day number here. Does that make sense to everybody so far? It's kind of weird. Like I said, I feel very uncomfortable when I create a separate variable to increment when I'm already inside of a for loop. But in this case, it actually makes sense. And so what Ashu said was we can just use an if statement. If we can think about the logic behind it, we can turn it into code. So once we hit 7, Sunday's at index 6, right? Because there's 7 days in the week and we start at 0, so it's 0 to 6. So after we hit 6, the next one we just want to restart the index at 0. And so there is a complicated way I'm going to show you in a second, but the easy way, if you don't think of the complicated way, is we can just say, well, if our index is greater than or equal to 7, index plus or equals 0, and reset it again. And then we can print out our days at index. I think I did that right. And yep, there you go. We can see that it is properly going through the weekday now. Any questions with that? I know it's pretty weird.
Yeah, could you repeat that? I'm sorry.
No problem. All right, so if you imagine the index for our weekdays starts at 0 for Monday, and because there's 7 days, it ends at 6 for Sunday, right? And so as soon as the index would be 7, that would be out of the list's range, right? There would be an index error that would happen on Python, which we were getting earlier. We want to prevent that, and so basically as soon as we hit index 6, the next day after Sunday, we want to just reset the index of our list to 0. And so what I've done here is basically we're incrementing our index every time this for loop happens. So we start out at Thursday, which is 3, we'll move on to Friday, blah, blah, blah. And we'll increment our index every time basically the for loop moves to another day. And so once we hit to 7 though, before we try and access our day at that index and we'll get a Python error, we'll just say, well, there is no index at 7, just reset index to 0 every time we hit 7 to the end and just put it back to Monday. So essentially what that does is it'll kind of loop around from Sunday, it'll just restart to Monday. You'll be able to do that. Does that make sense? Did I?
Yeah, better, thanks.
I feel like I said the same thing twice. I don't know. Okay, great. So we can do that, and now that we've done that, we can print out kind of a format statement, and we can kind of try and replicate this thing. So we want the weekday, we want a comma, we want the abbreviation, and then the day number. And then we can just do .format. You put a thing there. Then we can pass it the weekday, the abbreviation, and the day number, which is going to be I in this case. So if we do that, I don't know why it's angry. It's lying. It's not lying.
The comma. Listen.
Oh, thank you. Where's the comma? I'm not finding the comma. This comma? Wait, no. Oh, it's this. You mean a parenthesis. There we go. All right, so as you can see, rather than try and build this dictionary yet, I'm going to verify the keys are working the way I thought. And so we can see that, you know, our for loop is getting our day number correctly, and we're good. That's beautiful. Our month abbreviation was pretty straightforward. And then finally, our days index here is actually looping correctly and starting over at Monday after Sunday. And combining all those things and using our Python magic, we have created this beautiful monster. Does that make sense? Any questions with that? I know this part's been kind of tricky. Now, if you wanted to, we could go the extra mile and say weekday, abbreviation, and day num. And then we can go here and we could say weekday equals that, ab equals ab, and then day num equals I. Note when you use these quargs or keyword arguments where you have these pairs of information, like again, it matches this up and then it'll plug this data in there. You don't put spaces on either side of the equal sign. That's to say that these are paired together and you want them to be stuck together. And so this is a little more human readable. So we can see it's still going to work the exact same. And if you like it that way, that's nice. I approve that method. Ultimately, we don't actually want to just print this out. We want to store it. So I'm going to say our key is going to be this thing. And then now that we've got our key, all we have to do is build our calendar now. Remember, we started it out with an empty dictionary. And so we're going to say our calendar. And notice that this is our key and that none is the value. So I'm just going to say calendar at key equals none for each of those. And remember, each time the for loop happens, the key will be different for each different, date of the month. And so we've created our calendar, key value pairs, and we've returned it at the end. And so now, if I run it, first of all, it's all good, but let me print it out so you guys can see it. That's difficult to read as a human. There's actually a Python library we can import. We're going to talk about imports later, but you can note this one. And so I'm just going to do pretty print, put one more P in there. We've imported a library from pretty print, import pretty print. And what this does is when we run it, well, it organized it a little bit differently. Why do you think it did that? Anybody know why it's in this kind of order like this?
It's a dictionary.
Because dictionaries are unordered, and you can never expect the output to be what you think. All right, so does everyone understand what we've done here to build this thing? Any questions about that? I know it's kind of tricky. I recommend if you're confused by this at all or any of it is blowing your mind right now, go back through this and step through it on your own in a REPL or something. Try and reproduce what we've done here, and hopefully it will make some sense. Now, I do want to blow your minds a little bit though, just because I'm evil. And so we can do this way of having this thing start over on Monday again another way. So I'm going to comment this out, and this is pretty funky, but I'm going to say index, I guess I'll say normalized. It's kind of a weird way, but I'm going to say index modulo the length of our days. And then I'm just going to plug in that into our thing there. So what this does, and I know this is just being fancy and over the top, but this is kind of, does anyone remember what modulo does?
Gives you the remainder.
Right, so if you guys haven't done remainder in a million years, it's, remember, when you do a division problem, if there's any excess thing, if it doesn't divide evenly, it's going to be whatever's left over. So if you did 7 divided by 3, well, 7 doesn't divide by 3, so there'd be 4 remainder. So anyways, this will do the same thing. Imagine each weekday. So if we have Sunday, so the length of the days is 7. All right, I'm going to walk you through this. This is purely for trivia right now, just to show you guys some cool stuff. But the length of the days is 7. And so if we have 7 modulo 7, it's going to be 0, right? It's going to divide evenly. Okay? Imagine how that works. As soon as we reach the end here, remember the last one that's in our list is 6. As soon as we go to the next one, it's going to be 7, the one that's outside of our list. And so if we do 7 modulo the length of this list, which is 7, the remainder is going to be 0. And it's going to put us right back at this index. It's going to do the exact same thing this is doing. If our current index is 1, and we do 1 divided by 7, the remainder is going to be 1. All right? And so in that case, we stay the same thing. If we're on Thursday and we start at 3 divided by 7, the remainder is 3, and it just stays the same. So this modulo thing is only going to change it if it goes out of the boundaries of our list. Really fancy way of doing it, and it's just there to show off, basically. So I'm going to leave it back the other way. Any questions about that? I know that's really complicated. All right. So the thing still works. We get our dictionary, and it passes the test. All right, so we've taken the time to replicate this empty calendar. It's actually pretty nice. This thing is real. These dates are real. And we've made it dynamic, so we can change the month, and we can change the first day of the month, and we can create any calendar we want. Now, it doesn't take into account leap year yet, but that's only in February, so we don't have to really worry about that right now. But yeah, although we are using February. All right, so the next thing we want to do is we want to store our value. All right, we need to make sure, ultimately the whole point of this calendar is not just to see the date, but it's also to like put information in there. All right, so we're going to do that. I'm going to create another function called add task, and we're going to actually end up doing this 2 different ways, and I'm going to explain why we're doing it 2 different ways after we see the pitfalls in the first one. We're expecting to receive a calendar, which we've already created, this calendar, the day of the week, and a task or activity we want to put in this. So ultimately, when we build this calendar, our design goal is to make it, if we pass it Wednesday, we want every Wednesday to fill in the value. So this is going to be like recurring tasks. We want every single Wednesday to replace the none that's the value with whatever the task is here that the user passes. All right. So I'm just going to kind of walk you guys through this because of time and not ask as many questions. But if you have any after I do it, let me know. So the first thing we want to do is we want to create, we need to find out if our weekday is a match, right? If they pass in day of the week is a Wednesday, we need to make sure we change the values for all of the Wednesdays. So let's get started with that. How would I loop through our calendar how would I loop over my calendar? What's a good way to do that?
For loop.
All right, so yes, so for key and calendar. Now for this particular one, I recommend we actually use key value and we use dot items. It's nice to receive a little bit more information in this situation, and generally dot items is really handy. So that's going to be probably my favorite method for dictionaries to use here. All right, and so I want you guys to think about when you say for loop, do I need just the key, just the values, or the keys and the values? Is it going to be helpful for us to do that? All right, and so all we're going to do is say if the key dot starts with, so you're not familiar with this probably. I'm going to explain that one. Starts with is a string method that if our string that we're looking at begins with whatever we put here in these parentheses, so if our day of the week is Wednesday and our key starts with the word Wednesday, then we want to do something with that. Does that make sense? So we're just going to use that one. And in that case, if the key is a match, we're just going to say, well, first of all, we're going to make a calendar to store this in. And I'm going to explain that in a second. And so if our key has the weekday that we're looking for, we will just say our new calendar at that particular key is going to equal task. And so we'll just remember how if we have the same key and we try and create another key value pair, it'll just overwrite the current value. So our none here, we're going to overwrite that with our task. And then finally, we're just going to return our new cal. And so if I print out our calendar, I'll say, well, I'll just print out for now. Print out add task, calendar, Wednesday, and then programming. And if we do that, we will see quickly that we have taken our beautiful dates we took the time to create, and we've changed the value from none to our task. Now, there's a problem with this. We spent the entire time creating this amazing calendar, and we just lost, well, in this month, what, there's 4. And so we just lost like 24 other days of the week, basically. And that's unfortunate. And so that's not how we want to do. We want to kind of maintain the original values and only change them if they are that day of the week the user is searching for. So I'm just going to move this here. And so what I've done here is I've made this function so it's not doing anything. Right now, if I do this, we're creating a new calendar. We're looping over the key value pair in our old calendar that we're getting the data from. And I'm just saying the new calendar at key equals task. All right. So if I print this, now every day is programming, and you guys have no lives anymore, right? So it's not exactly where we want it to be. We could also say for new key equals value. And that's literally going to copy over the original calendar into this new one. And so we're getting somewhere, because now on those days that we're not trying to change, we're going to retain them because we're just copying over the key value pair. All right, so we're almost there. So now the last step is, if we have a matching day of the week, we're just going to we're going to overwrite our value with our task. All right, think about that. If we don't enter this if block, we're just going to copy the key value pair as it is. However, if it's the day of the week we're trying to change the task for and override the task for, then we'll say the value we're looping over right now is none. We're just going to overwrite that variable for value for that current one and write task into it instead of none. And so finally, if we run this, we can see that now on Wednesdays, you guys are programming with a lot of exclamation marks. Does that make sense? Any questions with that? All right, so some of you might have asked, or maybe you didn't even think about this, but why did I create a new dictionary in here? Why did I not just change the original dictionary right here? You might be asking yourself that. I don't know if you are or not. So there's a reason for that, and this applies to other collections as well. We do not want you to, well, Python doesn't want you to basically, if you imagine a list, I'm going to tangent for a second. If we have a list, and we have 1, 2, 3, 4, and if you happen to say for elem in a list, print elem, right? That's going to be fine. Nothing crazy is going to happen. I need to put an equal sign. Whoops. We'll see that, and it can print it out just fine. However, if I was doing a list dot append the number 5, you've just created an infinite loop. Because what you're trying to do is you're trying to loop over something that is constantly growing as you're looping. You've got kind of like a moving target. Can we do new calendar equals calendar? So there's a cool way I'm going to show you. I'll show you in a second how we're going to deal with this. So the problem is if we were using our original calendar here that we don't want to change the values or the keys of it while we're looping over it, because it can cause problems, because Python is trying to keep track of where you are in that list or in that dictionary, and if you're changing the size of it or changing the data in it, it's going to get confused, all right? And so as a rule of thumb, we don't like to change our collection while we're looping over it. All right, and so in this case, what we've done is we're looping over one collection, the original calendar, and we created a new calendar that we're actually changing and manipulating. We're just kind of copying over the data to our new one. Does that make sense? This is to be safe.
Doesn't Python throw an error if the size of the dictionary is changing?
Yeah, sometimes it doesn't. You kind of have to be careful with it. Like if you're not creating, in this case, we're not actually creating a new key value pair. We're overwriting values for keys that exist. And so the length of these is not actually going to change. So I don't think if we actually were using a calendar, it's going to throw an error. But I want you guys to be in the practice of not letting that ever happen. And so I want you to always loop over a different collection than the one you're changing. So you might describe this solution as an immutable solution, meaning we are creating a new calendar rather than changing the original one. All right. And so instead of printing this, I can say calendar equals this thing. I can do this a couple times. I can say Monday is the same, and then Friday is World Cup. I would say football, but now it's really football. So if we run this and we print out our calendar here, what's going to happen is we are creating a new calendar every time in this immutable operation. It's kind of inefficient. Basically, we're creating a new calendar, storing it, and then passing that new calendar as a parameter to the next one, and then changing that new calendar again, and then doing the same thing each time. And eventually, we can see on Monday you have programming, on Wednesday you have programming, and on Friday you have World Cup, because that's happening. And so this works. This is an immutable method, and immutable function, and sometimes that makes sense to do. Again, that may happen if you want to preserve the original data, or there's situations where that's good. However, it's important to know that there's mutable ways to do things as well. So if we wanted to solve this same problem with a mutable way, we can do that as well. It's just a little bit different. So we'll say, let me copy and paste that, actually. So we've got our add task function here. And remember, the reason we did not loop over this is because we don't want to loop over and change the thing at the same time as we're looping over it. So to handle that here, we are going to actually create a helper function. And this is a little bit weird, but it'll make sense once we finish it. So we're going to say find keys for days of week. All right, and we're going to pass it a calendar and then the day of the week. This is going to be a helper function for the add task function once we get done. And so what we're going to do is we're actually going to store a list of these keys that we find that are matches. And we're going to say for keys in calendar, if key dot starts with the same kind of logic we had before, day of week, not day and month. Then we're going to just say keys.append our current key. And then finally, we'll return our list of keys. So what we've done there, if I print that out real quick, I can say, fine, that's a really long function name. We're going to pass it our calendar. I'm going to say Wednesday. If I do that, what have I done? I need to press pass here. Hold on. If I run this, dang it. There we go. We can quickly see these are the days that we've stored them in a list with this helper function. We've created a new list and stored all the keys that are going to match that we're ultimately going to want to update the value for. Make sense? We've done this for a reason. I know this seems kind of weird, but we did this so that we can call it in this other function. So I'm just going to say the matching days, and we're going to call this function, and we're going to pass it the calendar and the day of week. And then once we get that, we can loop over that for day and matching days, and then we'll just overwrite the key with the task on there, and that's it. Now, I'm going to explain what just happened because I just went really fast. Now we have 2 collections instead of just 1. Remember here we had to create a second collection. It was another dictionary. Here we've made a list of all the days of the key, that we want to update, and we've taken all the keys that are going to match, right? So we're going to have, you know, this entire key for Wednesday, this entire key for Wednesday, and so on. And we're going to store all of those in a list like this. The advantage to this is now we can loop over this list that we just created, and we're going to be changing a different collection. We're going to be changing this calendar dictionary, and we're not looping over the same collection that we're changing. So we created a second collection that we did that. Does that make sense? Now we're not going to have a problem when we're looping over something that's like a moving target or changing. And so if we do this and we print out our add task, and we'll say calendar, Wednesday, and programming. If we print out our calendar, we can see that I didn't type the word key correctly somewhere. 111.
Should be D.
It should. Thank you. All right. So in this case, a couple things are happening. We can see, first of all, that this thing is working. I can do Monday as well to show that it's working. So now Monday has programming, and Wednesday has programming, just like you guys do. But what happened here? We have 2 nuns above this. Why do you think that is?
There is no print or return statement in the function.
Right. There is no return statement in this function. And so that's going to be confusing to you guys in a second. And I'll explain that part. But you might get angry right now and say, well, why are we not doing return calendar here? The answer is because we don't have to. Dictionaries are mutable. And in this case, we are taking advantage of the mutability of dictionaries here. And so what's happening is when this function is, when we're calling this function, we're passing in a reference to our collection. Our collection's a dictionary, right? And it's just saying, all right, our collection, it's like a reference, like a pointer to it. And what's happening is we're changing the stuff inside the collection, but the pointer still remains the same. The pointer is at some other location in memory outside of the function, all right? And so we don't need to return it. Imagine a bucket, and the bucket holds a bunch of data or key value pairs or whatever you want to say. The bucket still exists somewhere outside of this function. We're passing the bucket here for a second for us to, change the contents of it. But at the end of the day, the bucket still exists somewhere else. And so we don't actually have to return it. It's just sitting somewhere else. We're just temporarily passing a way into that bucket for this function so we can change the stuff in it. But the bucket stays outside. How is that analogy? It's a new one for me. Everyone okay with that? I will take your silence as a resounding, that was an amazing analogy. All right, so we can see that this way, both of these 2 ways work, first of all. We can have this, where we have the immutable way. And then we can, again...
Can you write something like return void to avoid the warning?
Return what?
Void, like a void type.
Return void, like this, you said?
Yeah.
We don't really have... You could return none.
None, okay.
But by default, if you don't have a return statement in there, it returns none anyways. And so it's a little redundant. All right, so this way works. I like the mutable way a little bit more personally because you don't have to keep overwriting your calendar variable here like we did here. and then sending that new variable as a parameter here over and over again. This is a little bit inefficient. However, it depends on what you're doing with the code. You might not want to change your function or your dictionary. You might want to create a new one. It depends on how careful you are with that data. And one important thing to note about this, with the fact that you don't have to return something, and you can change a dictionary from within a function and have those changes be reflected outside the function. Same thing with other mutable collections, by the way, is that if you have, say, a dictionary you create all the way at the top here, like this thing, if somebody else passes this to their function, they could change it in their function, and those changes would then be reflected afterwards after they ran that as a parameter in their function. And so you have to be careful when you deal with the mutability of collections and passing them to functions, because if you're working with a teammate and they're doing something like an add task function to the same dictionary you're working with, they might change the dictionary before it gets to you, and you might not be expecting it, and it might break the internet or something. Does that make sense? So just be careful regarding the mutability, and make sure when you're designing your code like this, you're doing it deliberately, and you know what's going on, and your teammates also know what's going on. Any questions about that? You guys are really quiet. You're either blown away or I'm teaching really well. We'll find out in the homework assignments. So one last thing that I want to share with you guys, for you guys to think about, is also one last method for dictionaries that we like to use. Let me copy something down. So I'm going to bring this down here, and let me actually comment that up. Cool. So in some situations, you might have a lot of keys and values, and you might be curious how many values are shared amongst these. Like, I had this question before I taught this project a million times, that like, I kind of have the days of the month memorized, but I've never actually counted them. I knew there was 28 once, and I assumed there would be 6 and 5 for the remaining, 30s and 31s. Well, it turns out there's actually 7 31s and 4 30s. It's not as distributed evenly as you thought. Or if you had perhaps a string and you wanted to count how many characters or whatever. So there are situations where you'd want to count how many occurrences of a value happen, all right? Maybe you don't care about the number of days in a month like I do. So I'm going to show you how to do that really quick. We can just do, I'm going to create a function, count number months with same days, I don't know. And then I'm going to pass it the months with days. All right, and so what I want to do, and I'm going to show you 2 ways to handle this. I'm going to first start out with, I want it to look like, hold on, this. I'm going to spoil it right now. I want it to look like this. So remember, we're doing test-driven development, so we know that we're going to call our function here, and we're going to call it summary in this case. We know the result's going to be like this because I've done this 100 times. And we're going to compare that our summary that our function returns is equal to the expected dictionary that we get out. All right. So what I'm going to do is I'm going to create a result dictionary, and I'm going to return that. Before I write any code, I'm just going to get some free wins. Like I said, I like doing that. And so all I'm going to do is loop over this dictionary. All right, so I'm going to say for key value in, what's it called, days per month, dot items. And then what I'm going to do is, if this value hasn't been created yet, or hasn't been found yet, I want to count. So think about how we're storing, how the result's going to look. We want the number of days in that month, and then how many times it's occurred. So we're going to start the occurrence at 0, and every time we find another 31 in there, we're going to add 1 to it, right? So what I'm going to do is, you might think that I could just say result at key plus equals 1 every time we do this, and then return result. You might think that, but that's not going to work, because remember how plus equals work is adding it to itself. It's like saying result equals result key plus 1. Well, if you don't ever have result or the value associated at that key defined, you can't add 1 to it. Python doesn't know to start at 0. You have to create a key value pair at first in order to do that, if that makes sense. So what I'm going to do is, and you only need to create that, we could say result at key equals 0 for the first time, right? But if we did that, then every time, let me print this out. Okay, fine. Okay. So in this case, we can see that now every single month is coming out with the same day. Now, one thing is we need to actually make this the value that's the key, because we don't actually care about the month names in this case. So I'm going to say result at value is that, and so now we'll see the occurrence. All of them are 1. Why is that happening? Anybody?
It keeps getting set back to 0.
Exactly. We only want to start it at 0 the very first time. So how might I do that the very first time? You're muted.
Could call the length on that dictionary.
Yeah, but then you're not really going to know how many key value pairs. Like, you wouldn't really necessarily be able to tell if the length is 1, whether it's 31 and 28 or 31 and 30, or how big it should be. Close. What else do you guys got? All right. I'll give you. Wait, Brian, you got it?
We can do one thing, like we can use the if statement. If the value exists in result, we can increment with 1, or we can put 1.
Perfect. So we can say if the value is in result, then set it. Actually, if value is not in the result, so if we don't have a key value pair set up, remember when we do result, it assumes that if the result is dot keys, right? And so if or it just happens that our value, remember our value is the number of days. So if our 31 is not currently in our result dictionary, then we're going to say result at the key 31 is equal to 0. And then after that, we'll add 1 to it. And then every time after that, if we see another 31, well, value is now in the result. And so we won't enter this part and reset it to 0, and we'll just add 1 to it, right? And so now if we do it, we can see that it's actually counting the things correctly. Does that make sense to everybody? Any questions about that? All right. Well, that's cool. You guys either get it or you don't. The reason I'm showing you this is, A, sometimes you want to see how many occurrences of a value or something or a key in your dictionary, and this is a really handy way of doing it. But the other reason, the main reason I'm showing you this is because there's another dictionary method I want to show you that does exactly what these two lines are doing, and it's called set default. So if we do result.setDefault, and then we say our key name there, I know it says value. I'm actually going to change it. So remember I said there are situations where you need .items or not. We don't ever use the key in this case. So I'm going to say, and I'm going to change this for value because it's confusing. I'm going to change that, and I'm going to change this to values. then now this is going to make a heck of a lot more sense. All right, so in this situation, stop being angry, please. This line of code is going to do the exact same thing here. We're just going to say it's exactly the same thing as these two lines. So what it says is set default is saying, okay, I'm going to look in my dictionary here and see if this key is present. If it's not, I'm going to create a new key value pair with the default value of 0. And this is exactly what this is saying. I'm looking for my key in my dictionary. If it's not present, I'm going to create a new key value pair, and this value is the default value. So literally, you're saving one line of code here instead of two. But this is kind of a fancy way to do it. If I'm giving you a job interview and I see you set default, I know you program in Python. If I see you using all the features of Python, I know you're reading about it, you're actually coding in it. And so this is a nice way to kind of show off that you use the language. And so yeah, that's set default. And it's just one line instead of two, and it does exactly what this does. So if I run it, same thing happens. And so if you ever have a question, what does set default do? It does these two lines. And this is where I was saying having meaningful variable names is handy. I had value there. It was really confusing saying is value not result when we're really looking at, remember, result is looking at result.keys by default if you don't say what it's looking at. And so that's it. Any questions about all this? You guys are really quiet. I hope you guys got all this. All right, so to close, I'm going to share this thing. And then for your homework over the weekend, remember we're going to have another quiz here. It's these 5 assignments. And then you'll also have your stuff for next class, which is a fair amount. You're looking at these 9 assignments in these videos here at report class. So you guys have, I don't know, like what, 4 or 5 days to do all of that. So I would just say get to work. And some of these ones are tricky. And so remember to use the mentors if you can. So you don't sit there, you know, like with your mouth wide open, you know, so use the help. Any questions? Comments? Okay. Well, that is it for today. Have a good weekend, everybody.
You too. Thank you.
All right, you're welcome. Keep on coding.
Goodbye.
See ya.
Why? We didn't talk about the leap year again. Maybe next time.
Oh, the what thing? What was your question again? Yeah, let me see.
We could do the leap year probably next time. So I didn't get it.
Oh crap. Dang it. So really quickly, the leap year thing would just be if you wanted to expand on this project. Let me actually share my screen again. Thank you for reminding me. Normally I'm on top of that one. If you really wanted to expand on this project, you could just, right now we've built a month. You could build a year. Now, I mean, think about what requirements you might want for a year. You still need to know the first day of the year and the year number, but you could figure out leap year based on, you know, you could do the, see if the year number is divisible by 4, and then you could add a leap year if you want to. So if you wanted to build a year calendar, you could do all of that stuff. And you can also, for future things, you could make it so you can store more than one task. You could maybe have each of these be a list. There's a lot of enhancements for this project that you could do if you're interested. And so I want you guys to think about those kind of questions. And if you're into it, go ahead and code them. You know, it's not that much more effort to turn this into a year-long calendar from what we have here. So that was it. I was just saying future opportunities. Thanks for reminding me. Anything else? All right, that's it then. See you guys next class. Have a good weekend.
Goodbye.
Adios.